So as I said before, we present our table in this format: test, observation, and then inference. Then the next thing is you read the instruction very well and stick to the instruction. So here it says C is a double salt. Carry out the following exercises on C. Record your observations and identify any gases evolved. State the conclusions drawn from the results of each test. So say, put all of C into a test tube. From the yellow paper, we are asked to take a spatula full of C. So so we're going to take a spatula full of the unknown salt. A spatula full. And then we put it into a test tube. So that is the instruction. Put it in a test tube. Say add about 10 cm cube of water. If you don't have this, you can just take an approximate volume. It's not a must that it must be exactly 10 cm cube. Do you understand? So you can take an approximate. So this is 10 cm cube of water. So we add it to the salt. Add it to the salt. And then stir and test with litmus. Test with litmus.
Okay, sir, the one in this thing, they say add about 10 centimeters.
No, 5. That one is 5.
Then here you're adding how many?
10. Is it water?
Yeah.
It's 10 cm.
We dissolve C in water. Now, after dissolving C in water, what can you observe? Because you always observe every step you take. Every action you take, you make your observation. So when we added water to C, what did you observe? What did you observe? You can see that we have a clear solution, isn't it?
Yeah.
Can you see where is the C that we put inside?
It has dissolved.
It has dissolved. So that's an observation. You said C dissolves, right? Now, what is the color of the solution formed?
It's clear solution.
It's not. It's clear, but it has a color.
Pale.
Pale green. This is a pale green color, isn't it? It's pale green. It's pale green color.
So C dissolves to form a
Pale green solution, yes.
Yeah.
So that is the first observation. So in this place, I will now come and say C
plus 10 centimeters.
for 10 cm cube
So, but why are you using cm cube?
of water.
Why are you using 10?
That's what I use now. Merely 10 cm cube of water. What is
Now,
the
what's the name of
observation?
that?
So from this test now, we can now know C. So C plus 10 cm cube of water. What is the observation?
C dissolves to form
C dissolves to form
a pale solution.
A pale light green solution.
a pale green, or you say a light green, anyone. A pale stroke light green solution. Can you see that? All right. So what will be the inference? What will be the inference? If C dissolves to give a pale blue,
It's a soluble salt.
yes, you say C is a soluble
I thought they said we should use litmus.
salt. It's step by step. We are going to use the full litmus and see the one that will have the effect on it. So we'll start with.
Because we don't know the salt.
Let me start with red. We don't know the salt. We don't know what it's going to give us. So you use the two to test. So let me start with the red. I will dip the red into it and see what is going to happen. So this is it.
There is no effect.
You can see
No effect.
it has no effect on red. litmus. So let's also look
That
at
means
blue.
it's
Let's look at blue. Wow, you can see now.
acidic. Huh?
So it has turned the blue litmus to red. So what will be the inference now? So we come back to our test. I will now say plus litmus, or you can say C aqueous plus litmus. Anyhow you want to write it. Say plus what?
Litmus.
Litmus. What is the observation?
It changed.
C
Is
turns
turns red litmus unchanged.
blue litmus.
Red even.
Paper red. So what will now be our inference here?
C
C is acidic.
C is acidic. C is acidic, or you can say C is an acidic salt. Anyhow you want to put it. Then the next one. What is the next thing? They say divide the solution into 3 portions. So we are going to divide this solution into 3 portions. So I will divide into 3 portions, just a little in each. I will divide into 3 portions.
So where are the portion?
This is the portions now.
One. That one is small.
I will add a little more to it. Okay. So we now have our 3 portions. Alright. So we have divided C into 3 portions. So that's how to follow instruction that is given. Now the next question, they said B to the first portion. So here we come. Question B says to the first portion. So we say first portion
Of C.
of C. So they said to the first portion, do what?
Add sodium hydroxide.
Add sodium hydroxide in drops and then in excess.
That is plus NA.
This is sodium hydroxide, but I don't know whether this one is still. Maybe I should pour this one out and use a new one, okay, so that we can use it. I can also use it for here, but I just want to pour out. Alright. So they said to the first portion. So let's say that this is our first portion, right?
Yes.
So they said to the first portion, do what?
Add in
Add
drops.
sodium hydroxide solution in drops.
Then in excess.
In excess. So let's add in drop and see what happens. What can you observe?
A blue-black precipitate is formed.
Oh yeah? Dirty green. This is what we call dirty green precipitate. Can you see it? Looks like all this army uniform.
Yes.
Dirty green precipitate.
Precipitate.
So you report that in drops. Or we can complete the test at once.
Yeah.
Now let's add in excess. Let's add in excess. You can even pour it.
See, this is when you see the color well now.
What can you say? Did it dissolve?
No.
No.
Insoluble in excess. Dirty green precipitate, insoluble in excess. So that's
Dirty
what-
green precipitates when sodium hydroxide was added in drops.
Yes.
Then
First
insoluble.
portion of C plus sodium hydroxide, aqueous, NaOH,
Aqueous.
aqueous. So what is our observation? Dirty green precipitate is formed, right?
Yes.
Is formed.
In essence.
In
Which- Okay, is formed in drops.
yes.
And essence. Or you can just say form in essence.
You can just say is formed, which is insoluble. Water. There's water in it. is formed, which is what? Insoluble in excess. In excess. Or you can say in excess sodium hydroxide solution. If you want to be very, if you want to describe it at length or in details, you can say which is insoluble in excess sodium hydroxide solution. So what will now be the inference? What will now be the inference? When we added in drops and a dirty green precipitate is formed, the inference there will be what? Ion 2 ion may be what? May be present. Then, when we now add excess of it and it is insoluble, you now say what? Ion 3 ion
may be present.
Confirmed.
Okay, confirmed.
Yes, ion 3 ion confirmed.
So you can write ion 2 ion may be present when added in drops.
Yes, when you add in drops and you get a dirty green precipitate, say ion 2 ion may be what? Present. Then when you add in excess and it is insoluble, then you now say what? Ion 2 ion confirmed. Ion 2 ion confirmed. What is the next question there? Say heat the resulting mixture and keep for some minutes. So we are going to we are going to heat now. We are going to heat now. So
This one that Momo is not here.
So we're going to heat. What can you perceive?
Ammonia.
Just a little.
It's ammonia.
Don't be afraid. Don't be afraid.
So a gas is involved now.
Yes, ammonia gas is
The
involved.
colorless gas that is involved from the up here.
Yes.
So say a colorless gas with a pungent smell
Yes.
is involved, right?
Yes, that's observation.
Now you can also test it. You can test that gas using
Litmus.
red litmus. So let's test the gas now using red litmus. Let's wait it a little. That's right. So we are going to place this litmus here and then heat a little. Oh, without even heating.
The gas.
So can you see now?
That gas is basic.
Yes.
Yes. So what can you say? A colorless
It is
gas.
NH3.
A colorless gas with a pungent
Smell.
scent, a smell is evolved, which turns moist red litmus paper blue. Can you see that? So don't switch off yet. So what will now be your
Inference.
inference?
NH3 is present.
Okay,
NH3 is present.
but before that, let's. Okay, maybe I should keep this thing down. If you want to test further now, you can now dip a glass rod in conc HCl and then place it at the tip of this test tube.
Yes. Then in white.
Yes,
The
white
white
dense fumes of ammonium chloride will be what? Will be formed. Because the ammonia will combine with the HCl to form
ammonium
ammonium.
chloride.
Go down on now.
Yes, I'm just saying if you want to go further.
I'm not going for that, please.
But if they ask you to bring
A wide rod.
maybe dip a glass rod
For
in HCl and place it close to the mouth of the test tube, know that that is what they're asking you to do.
That's why we'll read the question first.
Yes. So
NH3 is present.
say plus heat, Abi?
Yes.
Yes.
Plus heat. So when you heat, what will be the observation?
A colorless gas with a pungent smell.
With a pungent,
Yes.
or say choking, a pungent stroke choking
smell
Which
smell
turns moist
is
to
formed.
red.
Is evolved.
which
turns damp or moist red litmus paper blue.
Red litmus paper
Blue.
So our inference here will be what?
And
Ammonium ion present or confirmed. And gas is what? Gas is ammonium. Do you understand? You can also say ammonia gas from ammonium ion present. That's another way to put it. You say what? Ammonia. You can just write it in formula form. Ammonia gas from what? Ammonium ion present. That's another way you can write it. It's either you write it like this or you write it like this. Alright, so we are done with that now. Okay, the next thing they say keep for what?
Few minutes.
For a few minutes. So we come to this place. This is BI, II. Say keeping for a few minutes. Keeping for a few minutes. Okay, I need to bring it down. I need to bring it down a little. Keeping for few minutes. So let's see. If you look at this place, you will see that it is forming a kind of brown color, isn't it?
Yes.
Rusty color. So if you keep it for some minutes, this solution is going to what? Turn brown, isn't it? So that is what will happen when you keep it for some minutes. The green precipitate will turn brown. So that is the observation. Green precipitate, yes, turns brown on standing or keeping, on standing. So what is the inference? The inference, remember that ion 2 ion is green in color, while ion 3 ion is
Brown, yeah.
So the inference is that ion 2 ion has been what? Oxidized to ion 3 ion. So you say ion 2 ion is oxidized to ion 3 ion. So then I think the next one is C. What did they say we should read? We see. Say to the second portion, add few drops of barium chloride. So, in order for us to be very sure that this is barium chloride, should we dissolve a new one or use the one? The level has fallen off, but I know that is barium chloride. So let's add is barium chloride. Even though the level has fallen off. So let's add. They say a few drops, right?
Yes.
So let's add a few drops. We don't have barium chloride that has already been. Few drops of barium chloride followed by excess dilute HCl. So let's add barium chloride.
A white precipitate.
So what is observed now?
A white precipitate.
White precipitate is formed. So we say second portion of
Second
C.
portion
Yes.
of C plus barium chloride.
Second portion
of C
C
plus
barium
barium
chloride
chloride
aqueous in
in
drops. So what is our observation? White,
White precipitate is formed.
precipitate
PPT is
is formed.
formed.
Then we now say plus HCl aqueous, right?
No, dilute HCl.
Okay, dilute, let's put it down with dilute plus dilute HCl
Aqueous.
So what will that give us? Remember, this is our test. This place is still test. Here is still observation. And this place is what? Inference. So now let's add dilute HCl. Let's add dilute HCl. We should add what?
Dilute HCl.
Followed by SS.
SS
So we add it in
dilute HCl.
SS dilute HCl. So what can you observe?
See the white precipitate.
White precipitate did not dissolve. So you say white precipitate insoluble or does not dissolve in excess dilute HCl. So what does that mean? Which reagent or salt gives us that
So
result?
for
Gives us that result. So in the first place, white precipitate is formed. Okay, the inference we have not written that.
we are not yet sure that
Yes, we are not yet sure. So you come to this place, you say sulphate ion, sulfite ion, carbonate ion may be present. May be present. So that is the inference there. When you add barium chloride and you get white precipitate, these three ions, any of them can be what? Present. Because each of these ions will always give a white precipitate with what? Barium chloride solution. Do you understand? So how do you now know the one that is present here? That's why we are now adding dilute what? HCl. So when we added dilute HCl, white precipitate did not dissolve. Right?
it's insoluble.
So yes, so observation is white precipitate insoluble
Salt analysis
in
nke.
excess dilute
Salt analysis nke.
HCl. So the difference there, the only
Na?
ion out of the three,
No.
or anion out of the three that will be insoluble in dilute